Bharat, start Jay Bharat.
Okay. Hello. Wishing you a delightful evening. I am Bharat Kumar from ECE third year. Today's special talk by Miss K.Neelima ma'am, Assistant Professor of ECE, School of Engineering, MBU. I am happy to invite our faculty, Miss K.Neelima ma'am, to deliver her today's special talk. Her main research includes VLSI and communications. Ma'am, please take over the session.
Good evening, one and all.
Good evening, ma'am.
So I am Neelima K. I am working as assistant professor in Department of ECE, School of Engineering, Mohun Babu University. Today, let us see what is the role of VLSI in emerging technologies. Generally, if you are looking at any object, the way you look at defines whether you are an engineer or not. So let me share the PPT. Let us see how we are going to move towards VLSI. Is the screen visible?
Yes, ma'am.
Okay. Here data might be a problem. Can I turn off my video?
Okay, ma'am.
Okay. Let us go into the presentation. Now is it visible in full? Am I audible?
No, ma'am. Audible, ma'am. Streaming లో రావట్లేదు.
1 minute. Again I will share. Is it now coming, ma? Are you able to see this?
Yes, ma'am. Yes, ma'am.
So let us look into the role of VLSI in emerging technologies. Already yesterday, you might have seen what are the emerging technologies, especially the edge technology. So here we look at how the VLSI has emerged out and what is its role in emerging technologies. Now, when I say the word VLSI, many of you would have a doubt. What is it actually? The name itself says very large scale integration, and you all know what are the levels of integration. Can I know what is the levels of integration that has started and now what are its working now? Any one of you can answer. Shall I make you remember? It starts with the SSI, small scale integration. Can you name some of them? Okay, then. It is medium scale integration, followed by large scale, very large scale. Now we are at ultra large scale integration. Now let us start our journey from known to unknown. What do you
Excuse
mean
me,
by
ma'am.
a
Would you please full screen?
I had made it full screen only, ma. It is not visible.
It is in slide view, ma'am, not.
Now is it showing, ma?
Yes, ma'am.
Uh, Now let us see the road ahead
Okay.
as the journey from known to unknown. So this is the very interesting part of any human being life. Now I want to know what you already know. Let us keep it as an interactive session so that you won't feel bored. What do you know? From where do you know? How do you know? What do you know means you will be the next question will be in what sense, right? Okay, suppose if a question is asked like, what do you know about yourself? You will be saying something like, what are your likes, dislikes, uh, what is your study profile, like that. Suppose if you are asked with your human body, what do you know about your human body? So we'll be saying like, it is a perfect integration of many organs which are strongly supported by bones as well as the muscles. So already you might have assumed like some of them are sensory organs, some of them are actuating organs, some of them are like filtering, mixing out, like that. So if you look at your body itself, it is a perfect example of VLSI. Like all the organs, how they are integrated within a single body. That is the main concept taken for integration. So our aim is to integrate as many number of devices as possible into a single chip, and that would be for the betterment of humankind. So if you look at some of the applications that we actually feel and use, so the basic ones like sensory organs, what are they? Okay, like the sensory organs will be like your eyes, ears, nose, etc. So all those sensors will be taking input in any one of the form, and it will be processed through muscle, through nervous system, communicated to brain. So these will be acting as sensors for our body. Now coming to the nervous system and the brain. Brain will be acting as a CPU, central processing unit, and it will be delegating the tasks for various ways. How to respond, what to and what not to. That is being decided by brain. And how you are moving, your walking style, how you are responding to one another. It is all depends upon how the signals are being sent from brain through neurosystem. Now coming to the heart, generally it will be in the shape of your fist, that is your hand fist. Now this will be acting like a master clock generator, and this clock generator will be usually sending the signals that we are pumping out the positive actions and negative actions. So we are balancing the oxidized blood and deoxidized blood. So suppose if you look at the stomach, it is almost the same as mixer. So whatever the engineering aspect we are looking into in a mixie, the same thing is being done by the stomach also. It just breaks down the food into pieces. It extracts the required forms, and then the other ones are let out as waste. And some of its part is being handled by kidneys. So kidneys will be acting as our filters. Whatever the muscular action you are going to do, it is nothing but actuation. So here itself, if you look at, all of these are the engineering aspects only. And basically this sensor, it is now running to micron to nanotechnology, and sensor is the very much required input device for every edge technologies. Then design of any computing units with the respective clocks will be developed. Then again, the mixer as well as filters are the basic ones where we are seeing in communications. The mixer design is the very crucial part when you come across the communication equipment. And if you see any signal processing device, the aspect of filtering out the unwanted parts will be taken care by kidneys. Now the actuation parts, as the robotics has taken a giant leap, we come across actuation devices more being in use. Like even if you see how the screen is being rotated in a phone, that also will be considered as the actuation. So there are many equipment that are coping up to make ourselves more comfortable to live in this world. Now, what it actually means, like how to create an idea to action. So first it starts with daydreaming only. You have to dream. You have to create an illusion. You have to add up your creativity. Then as usual, as like you cannot apply, so you need to stabilize. You need to have a strong determination. Then only the status alternation can happen. Then with a compulsion, it might be from external sources or within yourself. A self, as a self motivated individual, you need to go for action. So this is actually, I had taken this picture from our Vedic yoga. So from there I have collected this. But it is the continuous sequence which usually happens. Now talking about the basic one, that is idea. Where do we get ideas? Is it a special ability? No, not at all. Then how to get at the ideas? To obtain any idea, we need to go with uncomfortable situations. Whenever we face uncomfortable situations, only then we start to think how to overcome it, how to keep ourselves stabilized, how to keep ourselves comfortable. From there, the ideas will start to emerge out. So, previously, if you take with the automobile engineering, initially people were more comfortable with walking. Even if they are going for a faraway distance, they used to walk by taking his or her friends together. But later on, when the distances were very much large, they started to devise cycles, means bicycle. Then, even if the distance is more, but time is very less, you have to reach there urgently. Then, the evolution of motorcycle has come. Then again, suppose if you are undergoing various seasonal phenomenons, like sometimes it is rainy, sometimes it is sunny, and sometimes it might be an emergency case where you may not be able to drive, then the situation of a comfortable space has given rise to the idea of a car, and so on. it goes on. It won't stop anywhere. So it is not like we are comfortable with everything. Somewhere something will be uncomfortable. When you have that idea, you start to dream of how comfortable it would be if this situation is not there. Then it starts giving a creative imagination to it, where you will be artistically framing out how the structures have to be and what models can be developed. Likewise, it starts with inspiration. So go ahead, try to daydream, then take up it as a challenge, add your creativity, imagine, get inspired. This is what I want to say from this slide. Now, is it like all of our brains are working equally? Not at all. Some of us will be using our left brain, many of us will be using our right brain. So, creativity will be coupled with right brain, whereas logical, mathematical orientation and a sequence of thinking can happen only from left brain. So, have friends who think in both ways, or a group of friends with left brain being active and a group of friends with right brain being active. So, team up. Then only you can achieve whatever you decide to. Now, this is the slide which you might feel very boring, but still, I want to tell an important aspect in this. Now, when I talk about idea as well as how it has to be as an inspiration, we start with something like, I want this. That want itself becomes the specification. Now, in what way you want to achieve it will be the architectural design. Now, suppose if you want to add up any special features, that represents the functional and logical design. Where do you want to represent it? Represents the circuit level design. Now, the feasibility of that idea will be in physical design. Generally, physical design will also be undergoing certain steps, like you need to adjust the dimensions, say, like you need to partition, you need to properly plan, you need to place, then you need to perform whether it is able to satisfy you or not. So that satisfaction will be based on clock tree synthesis, signal routing, and timing closure. Then coming to the other one, it is physical verification and sign off. Here, everything will be like a thorough check. Then only after we are satisfied here, we go for fabrication, means obtaining a physical component which we can touch and feel. Then the packaging and testing, like same as like safeguarding whatever we are designed, and finally using it. Here the basic aspect is not with the idea, but using that idea, what you are going to apply and how many times you are going to use it. So learn as many things as possible, learn them, immediately apply them. In whatever way possible, group together with some of your friends, keep applying it. Now, coming to the role of VLSI, because this is the core aspect. Now, when we say the edge technologies, we talk about computers because they are the main processing units that are being used. So, here the VLSI technology will be occupying an area like how the processors have to be designed, and there might be other variations like pipelining, parallel processing, quad core processing, like that. And other components will be like memory and storage devices. Even though we talk about cloud computing, it is the device from which it has to retrieved back, and that is the semiconductor device. And that device we are calling it as memory and storage devices. Even if you take up your phone, even your SIM card will have certain memory, or the phone will be provided with some memory. So those memory devices are nothing but the semiconductor memories. It might be a static ones or a dynamic ones. Now coming to communications, the VLSI technology plays a very important role here. When we start about communication, it is like exchange of ideas, exchange of information, exchange of data. So here it will be through mobile phones as the edge elements, routers and modems as the middle elements. So you can have a vast or drastic increase in mobile phone usage, router design and modems. Because nowadays we are seeing Airtel is going to support at least 20 to 25 devices as per the challenge. So it is because of router design. So it is not like always only 4 devices or 5 devices are connected. It might be n number of devices. Now coming to automotive technology like automobiles, we have electronic control units. So there the communication related equipment where vehicle to vehicle communication is being established will be utilizing this electronic control units. And these control systems might be like engine, transmission, and brakes. Even the design of that control part as well as the fabrication part will be based on the VLSI technology. Now, coming to the medical applications, it is not like we are limiting ourselves only to the external world. We do explore ourselves also. So we go upon with VLSI technology with the development of medical devices, especially it has started long back, the pacemakers, because sometimes the heart might forget to pump out the blood. So during that time, as an alternative, pacemakers can be used. Nowadays, with the advent of IoT, even heart monitors are also being used. And the complete medical sensing and actuating devices come under VLSI technology. Apart from this, whatever the imaging systems that you are going to use, they are basically all are made up of technology based only. So, what does this technology mean actually? It is how much is the distance between drain and source if you take a conventional MOSFET. But nowadays it has been changed. We are moving towards new profound devices like CNT FETs, means carbon nanotube FETs, graphene nanotube FETs, then memristor, and so on. So, as the technology is advancing, even quantum dot cellular automata may also emerge where the atomic structure is being utilized for communication. So, the evolvement of VLSI will not be restricted. It will be a continuous growth. So, learning from semiconductor industry will be the best option that you have as you go out of this engineering college. You might get to know that semiconductor industry has been emerging out in a drastic manner with the support of IoT also, because everything it has to be based on sensing actuation for especially for IoT, then again storing, computing. So all these things combined together, the basis will be the semiconductors. So learn VLSI at the best possible, apply them as and when you get an opportunity. Now I want to ask you why I had kept this image. Can anybody answer? Are you all there? So this is one of the movie where many engineering aspects were shown related to communication, the bird flying and coming, giving the information, the way the transport of human beings has happened during a fight, how the natural calamities were used to their benefit. That was the image here. So there are many engineering aspects that are shown here. Of course, you also might have experienced. So this is all about the role of VLSI. Hope it was good. Now I want you to ask me as many questions as possible. Are you all there?
Hello. Any queries related to the VLSI, please ask in the comment box. If anything you want to know about the VLSI, you can ask freely. Madam will help you in that.
Okay, then one more opportunity I want to say you. Recently, as per my analysis, 25 semiconductor industry based companies have been started in various cities like Bangalore, Chennai and Hyderabad. So many of you have an opportunity to work with semiconductor industry, and many faculty are there who are specialized in VLSI, nanotechnology, communication, signal and image processing. You can use their expertise, learn as many things as possible, learn as many tools as possible, and don't forget, don't work alone, work in groups. And I hope every faculty will be ready to share their knowledge to you. And this is an unmeasurable opportunity for every student. You can go choose your own faculty, you can ask them to help, they will be every second ready to help you. And this will be useful in getting your jobs. Like in every interview, at least HR will look at whether you have published any papers, have received any certificates, have you thought any innovative ideas like that. So it gives a best opportunity to work upon this. If any student is interested, then we can work out at various levels of abstraction, generally starting from physical design, that is from layouts, circuit design, even new transistors development, followed by circuit design for signal processing, and nowadays even image processing. Then again at gate level, by using HDL languages, you can move ahead with that. And the higher order abstraction levels, where the integration of those designs is possible. I am open to questions. If you are going to ask anything, I'll be ready to answer. Indeed, I'm very happy to answer. I want to give you one more example, especially for VLSI. And now with the most advancing machine learning, artificial intelligence, etc. So generally, the reaction that you are getting when somebody is uh, overreactive or shouting at you or say in a aggressive behavior, what it actually you do? In general, our response will be like looking at what has happened. Very first option, looking at what has happened in a mysterious way. The second immediate action will be, can you guess? The second immediate action will be to get to know immediately out of anxiety. Now, the other one will be you will be reacting fast. Either you will be frowning, you will be showing your anger, or you might be making yourself cool so that you will be allowing the other person to come out of that emotion, right? What does this actually is the process? It is nothing but machine learning only, a part of machine learning. So our brain, it has been already trained for reinforcement learning, which you might come across in machine learning. Similar way, artificial intelligence, generally we have a problem like when we are being with a herd, like we say be like a Roman when you are in a Rome, right? So it is self-adaptive nature. So that is also one aspect of artificial intelligence. And now without the device support, means your human body, you cannot do that. Means underlying VLSI is the aspect that we are all undergoing through in our daily life for each and every second.
Hello, ma'am.
Ah, yes, ma.
Some queries from the students, ma'am.
Yes, ma.
What are the platforms for getting job in VLSI by Bablu Yadav?
Okay. See, when you talk about VLSI, the very first one will be the analog based design, especially at device development. You can devise your own devices as well as structures, and you can model them like how you have used your spice code. You have used some statement like dot model, npn, npn of, like that. So that model itself development can be one choice. The second one will be devising the circuits for end devices, like how the voice signal has to be processed, how the video signal has to be processed upon hardware. Next, the other one is the digital domain, where you will be seeing everything in a digital aspect. You will be utilizing the technology, and the design as well as testing will be will be as a combination, but there you might be working as a design engineer or as an verification engineer. And apart from this, suppose if medical aspects are coming into picture, or if you are giving support for mixed signal design, for say for like communication or medical equipment, then the role of mixed signal design will be coming into picture. And this is a somewhat difficult aspect, but still we can have a better idea when you are learning about mixed signal design as a subject. So we have basically
Ma'am,
three domains: analog, mixed signal, and digital. Among this, the design engineers will be one aspect, fabrication engineers another aspect, and the third one is verification engineers. Yes, ma'am.
by learning VLSI alone, can we grab a core job by Renuka?
Yes, of course, but you need to know where to apply. So, in order to satisfy that, you have to learn the other subjects also. But still, by learning VLSI, it means that you have to be thorough with at least one abstraction level design. You can choose any one of the designs, starting from physical design to system level design. You can choose any one of it. You have to be thorough with that. Then you can get a job in that.
Next, why hiring in semiconductor companies is very low as compared to software companies by Ramcharan.
See, the semiconductor industries were started in India recently only. So previously it was a limited number of companies which usually go ahead with NITs or IITs. So the rate of uh, means accepting people from other colleges or universities was low. But now the situation has changed. If you prove yourself in your interview as well as in written test, automatically you will be selected. And with the emergence of new companies, it has been possible from the last 2 years, the rate at which the students are being hired for semiconductor industries has been drastically increasing. Next, Ma.
Uh, is it possible to get job after fourth year or you can go for higher studies by Bablu Yadav?
We can get with BTech itself, where many companies are there. Like you might have to go with internship plus a job search. The second one will be like directly going for an on campus or off campus job interviews. So there the process will be like you will be having one or two written test, one or two levels, or nowadays it has gone up to 5 levels. Then after that, three or more, at least one technical interview and one or two HR interviews. And whatever be the company you are being placed, if you are able to make a drastic change in that company, then automatically you will be selected and hired for new upgraded companies. And it is possible even with BTech. And many of our students are also placed like that only. But previously it was with off campus. Now we are trying for on campus. And even with MTech, PG courses, you can get into VLSI or semiconductor industry. Not a problem.
Ma'am, can you explain what are these nanometer technologies by Mahendra Kumar?
The nanometer technologies start with usually 90 nanometer. Previously, it was 180 nanometer. Now the device scale down has happened. It was starting with CMOS devices. Then, as the technology was scaling down, multi-gate FETs were the new technologies that were used, including FinFETs, where fin-like structure of gate was used to allow the signal to traverse. Then, after that, further beyond 10 nanometer, due to some of the challenges, CNT FETs were devised. And these were also like single walled, multi walled carbon nanotubes and integrating them onto the MOSFET
The WAS
for
or
gate like structure,
WES credential.
they were utilized for many applications. After that, graphene nanotube FETs were also devised. Then, following to that, because many a times fabricating a resistance will be much more difficult when compared to the transistor. So, resistive memories or memristors were also formed. So, as the technology is scaling down further, even quantum dot cellular automata has become enabled. Still, the research is going on, and many nanotechnology based devices are going to come up. And there are many funded projects which are being done by the students at various institutes which are aiming at developing new devices with good capabilities like the on currents and off currents, frequent switching, means as you want to use it at terahertz, the device has to support. So for that, they are going with devising new devices.
That's all, ma'am.
Okay.
Uh,
So I want to say one more thing.
okay.
In the VLSI and embedded system cluster, 7 faculty are there who work upon at various levels of abstraction. So students, whoever are interested, they can be, they are allowed and are pleasantly welcomed by the faculty of VLSI and embedded systems cluster. And we are here to help you to achieve whatever you want in relation to semiconductor industry as well as the embedded system based industry, means which is at board level. So till system level, it starts with the semiconductor industry. So there also we are going to help. Apart from that, even for embedded systems and their designs for edge computing, fog computing, etc., will be supported by our faculty. So all of you are welcome. Hope you utilize whatever is available.
And some other queries also there.
Yes, ma'am.
Nowadays, chip shortage is arising due to these companies. Will they show interest in us?
Chip shortage was actually during some recession times, but with the advent of new technologies, that shortage can be overcome within a few months. So certainly they will be taking you into consideration. Most probably we are expecting by September it will be cleared and everyone will be out of that recession. So September onwards, I think an uptrend can be seen in industry.
Next one, ma'am. Will nanometer technology affect the performance of the processor? By Mahendra Kumar.
Yes, ma, sure. At nanometer technology, the devices are very much close nearby. So instead of dynamic power being dominant, it will be the leakage power which is dominant. So the subthreshold regions, the leakage powers, and the dominant second order effects will be occurring there. So you must have proper control over this while you are designing the processor by using nanotechnology. Certainly it will be there.
Next one. What are the subjects we need to go in VLSA side? By Srinivasulu.
From your course syllabus itself, it starts with BEEE, Basic Electrical and Electronics Engineering. So whether you are quickly acquainting with the electrical or not, I am talking only about semiconductor industry, but every subject is important because in our everyday life, we are using almost every engineering subject to the best possible extent. So here it starts with electronic devices and circuits, followed by the electronic circuit analysis and design subject, where amplifiers, oscillators, and many devices with their circuits are being studied as power amplifiers, etc. Then you are coming with linear and digital IC design. So here an IC based approach will be seen and the modeling approach also will be seen. Means you are introduced to how you can model the devices there or the circuits there. Then after that, you are having VLSI system design. Following to that, you are having digital IC design. Then again, as an elective, low power VLSI design, analog IC design, mixed signal design, and testing and testability. These are the subjects within the core stream, which will be helping you in getting the semiconductor industry based job.
Okay, ma'am.
Yes, ma'am.
That's all only.
Okay, ma'am.
Uh, Thank you, ma'am, for providing your valuable time and being the part of this session and making the program successful. Thank you so
Thank you,
much,
ma'am.
ma'am.
Thank you, one and all.
Sir, end the session.